Hey everyone, today we're gonna be doing a lead code question which is to find most profit assigning work. So in this question we are given some jobs and worker array. Like there are total three arrays given to us, difficulty, profit and worker array. In the difficulty array and the profit array, the index I represent the difficulty level and the profit of a particular job. And in the workers array, the index J represent the ability of a jth worker, which that worker can complete a job with a particular difficulty level. So they are saying like for every worker, they can assign at most one job. Like each worker can do at most one job, but a job can be done by multiple workers. So if there's a type of a job, many worker can do similar job for a particular difficulty level. So they're saying like, for example, if three workers attempt the same job which pays $1, then the total profit will be $3. Like all three workers will be doing a job that pays only $1. So the total payout, you can say the total profit done by those three peoples will be like $3. If a worker cannot complete any job, their profit will be like $0. So they're asking like return the maximum profit that can be achieved after assigning a profit to a jobs. After assigning the worker to a particular job. So we are given some difficulty array, worker array, and the profit array. We need to find the profit. We'll look into it how we need to do this. Let's see the constant. So they're saying the size of a difficulty level or the profit level is equal, which is equals to n, and n can go from 1 to 10 to the power 4. Similarly, worker array can also go from 1 to 10 to the power 4. And the element inside that, like the profit level or the difficulty level or the we can say the difficulty level of a people or the difficulty level given for a particular job that can go from 1 to 10 to the power 5. So let's see how we can do this question with some example. So let's take the first example itself. So what I have like I have a difficulty level array. So I have some difficulty levels given to us. Um, it is like one, like two, four, six, 8, and 10. So these are like five different jobs given to us with some difficulty levels. And for each that difficulty levels, we have some profit assigned to it. So if a particular person do that job, a worker can do that job if they have the difficulty level equals to or less than their own difficulties. So they can get this particular amount of profit. So for worker doing the job with difficulty level 2 can get the profit 20. Similarly, for 2 or 4 is 20. For 6, it is 30. For 8, it is 40. And for 10, it is 50. Okay, so these are the profit given to us if we do this sort of a job with particular difficulty levels. So these are some difficulty level and the jobs paired to us. Okay, so we have this. We need to find what is the maximum profit a person total workers can get. So we are given a worker array as well. So we have some worker array where ith worker, jth worker have their own difficulty level. So for this example, we have four different worker having a difficulty level like 4, 5, 6, and 7. Okay. So if you see now here, a very brute force approach. What we can do, like, okay, we can ask every worker to get and search for the job which they can do. So if I say, okay, this particular person can go and do this job and this job because this is a difficulty level for the ith person. Okay, so this is a you can say difficulty level. So this is a difficulty level for person, and this is a difficulty level for a task. Okay, I have that. level for a job, right? Okay, fine. So what I'm trying to say, like, okay, this person go and will check like which sort of a job I can do with my difficulty level. So I'll say, okay, I can do this job, I can do this job, I cannot do this job. So I need to check, okay, which job with this difficulty level, like under my difficulty level, which job gives me more profit. So I can say, okay, with job level higher, like job level 2, or you can say difficulty level 2, I can get 10 profit. With difficulty level 4, I can get 20 profit. So this person will say, okay, I got how much profit? So it will say, okay, I got 20 profit because I can do this sort of a job. Okay. Now, if I say this sort of a person, like this person, has difficulty level 5, so I'll say, okay, I can do this job, I can do this job, but I cannot do this job. Okay. So if I do this job, my like the what to say profit will be 10. If I do this job, my profit will be 20. Similarly, person will do a job with profit 20. Now, for 6 level, like for person having difficulty level 6, it can do this job, it can do this, it can do this as well because it is having same difficulty level with respect to job. So it can do this one, this one, this one, in which this particular job has the maximum profit. So it can do a profit with like a profit of 30. Okay. So at last, like I have one person having difficulty and like it can do a task with difficulty level 6. I'll check, okay, this can be done, this can be done, this can be done, this cannot be done. So it's still I got like maximum profit 30 over here. Okay. So if you see like in total, how much profit I got? Okay. So in total, I got 30 plus 30 plus 20, which is 100. So for this case, I got a profit of 100. I got my profit of 100 for this given example, for this job array, like for this particular job array, which defines the difficulty and the profit level, this sort of a worker can do this job, like this can do this one, this can also do this one, this can do this job, and this can do this job. So which for each I can get this sort of a profit, which in total gave me 100. So this was the example, and we got the profit like this. So this was very brute force idea where the time complexity for this approach is like time complexity will be n into m. So where and m is the size of a profit or difficulty array, or you can say in total job array. So I have some job array where it is a size having n, my worker array having the size m. So our total time complexity will be order of n log m into n. Okay, similarly space I haven't taken, so it will be constant. Okay, so for this case I have used so much like time which I cannot afford because my difficulty level is it is going from 1 to 10 to power 4. Worker also go from 1 to 10 to power 4, but the element inside it can go from 1 to 10 to power 5. So in total, if I say okay, in total it can go from 1 to 10 to power 9, which cannot be done in a single for loop, or you can say single CPU cycle. So let's optimize this bit further. So this was the very brute force idea. So we have checked with a brute force idea. Brute force we have done. Brute force. We have checked for all possibilities. Possibilities. Okay. We have checked for all the possibilities. What we'll do next, we'll do a different approach, like we'll use some data structure called heap because we need the maximum profit from here. What if like I'll sort this one, or let's say like I make some pair like okay, with the most profit job, you can you can be done first. So what if I say okay, if I sort this array, if I sort this worker array in the descending order. Okay, so I have some another approach. Let's say the approach 2. Okay, I push 2, what I'll be doing, I will be doing worker dot sort. Okay, why? Okay, this is because what if I have this array? So let me again copy this array. Okay, I'll use the same logic over here. I have my array. Now, what I am saying, like, I need this particular array to be sorted in increasing order, the worker array. Okay, let this be sorted. Okay, I'll sort this array. So if I sort this array, it will become what? It will become 4, 5, 6, and 7. Now, as you see, like it was already sorted, but for namesake, we have sorted again. But for this case, we need to sort this in the descending order. I'll let you know why we need to sort this in a descending order. So if you look over here, I have some jobs, okay, with some difficulty labels, and I have this worker with some difficulty labels. What if like I'll sort both of them? Okay, what if I sort both of them? So let's say like I have this particular thing sorted in the descending order. The pairs of them will be sorted in a descending order. So something like I might be using a heap data structure because I need that data in the sorted form. So I have this heap. Okay. I will be making the pairs of them. So I will be using the max heap because I need the maximum profit and the maximum profit and the difficulty from that. So I will be creating a pair like I can have the data like okay pairs of 50 and 10, pair of 40 and 8, pair of 30. So let me take some small. So, so I have like pair of 50 and 10. I have pair of 40 and 8. I have a pair of 30 and 6. I have pair of 20 and 4. And I have a pair of 10 and 2. Okay. I have this sort of a pair. I just need to like iterate over here. So if you see, like, if I say, okay, this particular person having difficulty level 6 or 7, what if like I can remove all the difficulty level which is greater than 7 because none of this person can do task which is more than this person. If up, see, this person has difficulty level 6, 7, sorry. So this person can do a task only with difficulties level 7 or less. What if I have job more than this? So if you see these two jobs having difficulty level more than 7, if this person alone cannot do, how will this person will do? Because this person difficulty level is way lesser than this one. So for this, I can remove this part. Okay. If this person cannot do this job, I can remove this job because they cannot do by any chance because I was doing the job with my capacity. If this person don't have capacity, they won't will be having the capacity because I have sorted this in a decrement descending order. Similarly, this is you can say I'm using the max heap over here. So this is max heap. We will be getting the maximum element first. Okay. So for now, I just made this in the descending order because it is a max heap. It will be giving the maximum element each time. I will be having my maximum difficulties. You can say maximum profit, comma difficulty. So it will be giving me the maximum of both. Okay. In Python, it is like we don't have any max heap. I only have a min if, so I will be passing my this profit in the negative form and I will be like getting in the negative form again. So that way I can like tweak this min heap in the Python. Now if you see over here, uh, I can iterate. I can iterate over this number workers array. Okay, I can say okay, iterate over this worker array. For this worker array, I'll say okay, if if this was my worker array, this cannot do this job, so I can remove this one. Okay, I'll remove this one. Similarly, it cannot do this task as well. Okay, this seventh. a person with 7 difficulty cannot do this task, but this can do this task. So for this person, profit will become what? Profit will become 30. Okay, this can do this task. A person having difficulty level 7 can do this sort of task. And we have used the maximum heap, like max heap, based on the profit. So we will be choosing the first one only because I need the maximum profit. So for getting the maximum minimum, heap is the best data structure. So we have used this data structure for each particular person having job label something. We will be checking over here. So we will not be removing anything because multiple person can do a job. If you see for this person, okay, I have this person now. It can do this task, and this task. It cannot do this task. So basically, we have removed this from 7. So they are no longer in the consideration. So we will be checking over here. So I'm using the max heap. I won't need to iterate over this again. I can just simply take the maximum from here. So person this can do this task as well. So I'll say okay. For this also profit will be 30. Now if I say, if I move my pointer again, or if I point to the next person or next worker, if you see its difficulty level is 5, it cannot do this task, but it can do this and this. So I can remove at least this task. Okay, I just need to check for this alone. So for now, this was the maximum part. I can give its, like, I can get the profit from here as 20 because this can do at least this task because it is having difficulty level 5 and job has the difficulty level 4. So this can be done. This can also be done, but we are getting the maximum alone. Similarly, for this person having difficulty level 4, this can be done. So for this also, I got the answers 20. So if you see, we have optimized our approach. If you see, like we have done and we got the sum as 100 again for this case, the total sum. Now what we have done the sorting. So for sorting the workers array, so let's say this was m. So for sorting we got m log n. Okay, this was the time complexity for sorting this. And if you say for this heap, I was pushing this difficulty and workers, or you can say profit array. They might have like pushed what time? N time, because if I say it is having the size m, I can say they can be pushed n times, and if I'm using the heap, they will be like getting, you can say, restructured again using like tree structure. So this also be using our log n times for that restructuring. Okay. So in total, if you say I have done the sorting for this, I might have done the sorting for this, not sorting, but it's kind of sorting like heap sort, you can say. So m log n plus n log n. Now we are iterating over this array, this worker array. How many time? N time. For this, I'm iterating m times. Okay, and for each m time I'm just getting the top element from here. Okay, so if I can get top element in O of 1, but I need to remove some element sometimes, that can be done in log n time. Okay, n is the size of this particular difficulty array. So in total, like I'm doing m log n plus, I'm doing like m log n plus n log n plus m log into n log n. Okay, we can still optimize further. So this is one approach. You can easily code it. Like we need to create a pairs of this. We need to sort this one, and we need to iterate over this again. I can do a bit optimization over here also. So I can say, okay, approach 3 over here. Approach 3 says like, okay, do one thing, uh, don't create a heap. You can do like binary search in this answer, because if this array can be sorted in the increasing order, so if I say instead of sorting this array, I can sort this particular array. So I might be having a pair of them. So I might be having pairs of job, you can say job, in which I might be having my difficulty and profit. Okay, this will be creating some data, you can say some graph group like I might be having this group with data looking like in the sorted order. So I'll say okay, group of like 2 comma 10. Again I will be having 4 comma 20. Again I will be having 6 comma 30. I will be having 8 comma 40 and 10 comma 50. So this data is sorted based on the difficulty level. Okay. Now if I say I can iterate over this worker array and I can get the index. So using the binary search, I can say okay, this particular number, if I say 4, what is the index at which this 4 can come? So I can say okay, here it can come. If I say this is having some index value 0, 1, 2, 3, and 4, that means if something like if this particular person can do till here, if I say this is the range a person having a difficulty level, if I say this was the difficulty level with this person aligned with, so this person can do at least these many tasks. Okay. If I say for 7 it can get the range till here because if I say find the index 7 over here, so it can get the nearest smallest which is 6. So this can be having range like this. Now within this range, I need to find, okay, if this was the range, what is the maximum profit I can get? So for that also, what I can do, like I can replace all those values, like I can do the pre-computation again. So if I have created this particular, you can say data, like I have this structure again. I might be filling my data, like I have 2 comma something, I have 4 comma something, I have 6 comma something. Okay, I have 6 comma something, I have 8 comma something, and I have 10 comma something. Okay, I have my 10 comma something. Now something here means I might be replacing its value based on the highest value they have. So if I say okay, till here it is 10. Okay, till here it was 10 because it was the first value. We can carry forward the maximum value they have. Okay, so I can carry forward the maximum value. For now maximum is 10 for this case. If I include this case, the maximum will become 20 over here. Fine. Now if I include this task as well with job difficulty level 6, maximum can become 30. So it can have 30. For this it can have 40. Okay, till here it is 40. For now this is all those things are in the sorted order. What if I might having 10 over here? Okay. So in that case, like it depends like what will be the maximum. Suppose this was 20 and this was 10. So if I say for this it can get profit 10, but if I say for this range, maximum can carry forward to here with 20 instead of 10. Okay, so I can pre-compute this one. So what I can do, I can create a pair. I can create pairs of uh, difficulty label, comma, profit. Okay, I can sort them. Sort based on difficulty label. Then I can use binary search. Okay, before that I can do pre-computation. Okay, pre-compute compute this like maximum. Like I can get pre-computation of a maximum in the range, maximum value, maximum profit in that range. Okay, then I can use the binary search for that, you can say worker, to get the particular value. And the same order I can iterate. I can do the sum like for if I say person with this, it will get the range over here, which will be 20. If a person 5 will come, it will be also in the range 20. So again 20 will be added. If I say person with job level 6 will come, 30 will be added. person with job level 6, 7, again 30 will be added. So at last again I will get 100. So this was a one approach. Here I have sorted this array again, which will be done in n log n. Okay. For sorting this, I used n log n, but I haven't sorted my job array. So I reduce my m log n sorting from here. So which is reduced. Again, I was iterating. So I will be using the same thing. Like here I have took m log n for iterating and searching in the map. Similarly, for searching data in the binary search, I take log n. So this will remain constant, same. We have just reduced this part, like sorting of a worker array. Now, if you say like, okay, I might be using the same thing again and again and again. I will be using one third approach. So my third approach is like I'm using like I will be sorting both the array. So it is like the very you can say optimized approach, not very optimized, a bit optimized approach 4. I will be sorting both of them. So sort both job pairs, okay, and workers in ascending order, in increasing order. Okay, why to sort in the increasing order? Because if you see over here, I have that. Okay, let me copy that again. So I'll say, okay, take this array. I just need to place somewhere. Okay, so I will be doing the sorting over here. So if you see, currently it is like already sorted. Like we have this sorted order for this particular example. It might not be case for all of them, but for now I have this data as a sorted for order. Okay, so I not I might not be showing you that. So, but it is done the sorting based on the difficulty level and the workers level in the ascending order. Okay, fine. What we can do? Okay, for this I might have done the sorting based on n log n time complexity. For this, I have done the sorting based on m log m time complexity. Okay, that's fine. What optimization we are doing? We are optimizing this part n into log n times. Okay, so we will be optimizing that. How can we optimize that? I will be like checking. Okay, for this particular case, how far I can iterate. Okay, if this minimum person can do this minimum task with this particular profit, any person coming next to it will be getting at least this profit. So what I'm trying to say, if this person, let me remove this as well, remove this. Okay, if if this person can do this job and this job and can get the maximum profit 20 from here, okay, for this maximum is 20. So any person coming next to it, at least it can get the maximum profit 20. It can get more than that, but minimum it will be getting 20 profit, because a person having more difficulty level can do a job with a more difficulty level. So if person 4 and 5 can do this job with 4 difficulty level and get the 20 profit, person with 6 difficulty level can do at least this many tasks, like at least can do task among this and can get 20 as a profit. But it can do the maximum of 30 as well, but minimum it can get 20 instead of 10. Okay, so I will be like carry forwarding that particular maximum profit. So if I say, okay, for now, if this 20, if I say, okay, this 4 iterated till over here, it collected 20 as a profit. Okay, it iterated over here, again it checked for this one. So it will keep on checking, okay, which all task it can do, and it will be holding some maximum value. So it might be holding max profit for now. So it hold in a first go, it holded 10. If I say it iterated over here, it iterated over here and checked, it was 10. Again, it iterated because 4 can be done with this. So again, it was 20. So it was updated to 20. Okay, so it was updated to 20 now. Now, if I say my profit is updated to 20, fine. Now, if you see my next person coming over here, uh, this person 5. Okay, if this come, it is not required to work and compute again from 2 and 3 and 4, because at least this amount of profit can be gained for this person because it is having a, you can say, a job label greater than the previous one. So at least it can do the job with a difficulty level 4. It can do next to it, bigger to it, but minimum it can do this. Okay, so I can say, okay, it can start from this same profit label and it will check, okay, if this profit is more than me, I can move ahead, but if it not more than me, I need to stop. So it cannot get this one, but it can get this one. So I am not computing again this part. I am just simply writing 20 for this, 20 for this. I will be checking again for this one. So for this person, if I say, okay, for this person, at least it can do this task, but it can do this task as well because the difficulty level is 6 for now. So now my maximum profit become 30. It can do 30. 7 will come. 7 can do at least 30 profit task, which is 6. But it cannot do 8 profit task, 8 difficulty level task. So it will also get the max profit, which is 30. So in this order, we are just carry forwarding the maximum profit, and we are skipping the like the computation of a particular worker again and again, because we know if minimum like difficulty level task can be done in some order, why need to compute again? We can carry forward that result to some extent. Okay, so we can like pass our data to the next person with more difficulty level. So let me show you with some code example like how we gonna be doing this, because I see you might be getting confused what I'm doing and what I'm saying. So I might be having some indexes for which task or which job I might be picking up. I'm having the size of my worker as well, the profit as well. So for now, index will be starting from 0 and I have that job. Either I can choose the profit or the difficulty. Both will be giving me how many jobs are available. Okay. Now I need to make a pair of jobs. Okay. I might need them because I will be like I need to like what I need to do sorting based on the difficulty label. So instead of sorting two array, I can make I can club them in a single one. So for each of them, I have a label and I have a wages, I can say. Okay, the profit I will mark as a wages for now. So I'll say, okay, for profit and like for label and wages in in now in order to iterate both the array in a single go, I can use zip function. I'll say, okay, use this like one element will be coming from both. So it will coming from profit and one will be coming from difficulty level. So level will be coming from difficulty and wages will be coming from profit, and it will be making a pair of them. Now I need to do the sorting for both the things. So I'll do, okay, jobs dot sort, and in key I'll say, okay, key I just need to sort based on uh, the the first data like with difficulty level. So I'll say, okay, just I will be using some lambda function to sort based on the you can say difficulty level. So I'll say, okay, lambda, I will be passing some, you can say I have the item. I'll say, okay, it is item. I'll say sort based on the item dot first index. So it will be sorting me this data. It will be giving me the sorted data based on the difficulty level, because we have passed difficulty level as a zeroth index and wages in the first index. So it will be getting sorted. Similarly, I need to sort my worker array. Okay. This is worker array. This will be again sorted in the increasing order. Now I will be iterating over my worker array. So I'll say, okay, person, or I'll say person level, or let's say, just I'll say, okay, level. Let's say person alone. So I'll say person level for now. Okay, for person label in worker array, or I'll say worker level. Okay, I am picking one worker each time with their label in that array. Okay, I will be comparing. So I need to skip all those things which are less than the current worker. Like I have difficulty array. I need to skip all those which can be done using this person alone, because the next person coming with more difficulty level can be doing that particular task also, but we are not required that particular thing. So I might be storing my max profit for now, profit, and my total profit. Okay, total profit, which is equals to 0 for now. I will be checking, okay, if my index value is less than the size, okay, I cannot iterate more than my jobs available to us. Okay, now I need to skip all those which can be done. So I'll say, okay, job, in the job, I need to check the index. So I'll say, okay, this is my current job, the first job. If I'm starting from this index, I will check it. Okay, can my first job with difficulty level. So zero index means difficulty level. If it is less than or equals to current worker level. So if I say, okay, if it is less than or equals to this worker level, I can skip this part. Okay, I can skip this part, like, okay, this can be done. So next person can also be do and can also do this task very easily. But I can store that profit over here. So I might be maintaining my profit, like profit so far, or profit or maximum profit we got in each iteration. So I'll say, okay, maximum of next profit and the profit I have with this job. So I'll say jobs with current index and a profit is at first index. So I might be storing that particular profit as a max profit in the same go. And if my thing is done, suppose I got if a person having 4 difficulty level and this was iterated and completed, and again we got this job difficulty level as 5, this loop will get break. That means I got something which can be stored and computed. So I'll say, okay, difficulty level, we can say total profit can be done to the last known maximum profit. So whatever profit, maximum profit we have so far, that can be added to our total profit for particular worker. Okay, this can be done, and at last we will be returning our total profit. Okay, so it will be returning me the total profit. I will be compiling this code. Let's see if it is working fine or not. So yeah, it's running fine. Let me submit this code, and if we see like it got successfully compiled and it is like way optimized. Now let me tell you the time complexity for this case. So if I say for now the we are done the sorting with n log n, we have done the sorting for this into m log n. But if you see like we are iterating over the array, we are looping over this array which take m times. But if you see over here, this part, okay, let me show you. Okay, over this part, this alone. Okay, I'm iterating over the worker, or you can say job array, but at max n time, because if we are skipping some part, suppose we have this array. Okay, I have this part. If I have marked this one as a visited, like I have done iteration for this two things using this, like for this person I have iterated over till over here. So I have iterated over here till over here. I might not be iterating again for this particular case. So for 5, like for the person having 5 difficulty level, I'm not iterating over here again. I'm just simply picking the maximum value so far. for this, I was just iterating the next part. For this, I was not iterating anywhere. So maximum you can iterate over this array once inside the for loop for this worker array. So for that case, it will be like what? M plus n. So for this iteration, the final for loop, I'm using m plus n time complexity. Okay. So for this I took m plus n. Okay, where size of like m is the size of worker and n is the size for job. Sorting this array took n log n, and for sorting this, I took m log m. So we have done this sort, you can say, approach in m log n plus n log n, where it is a major part. So yeah, that's all for today's. Thanks for watching.